Calculate measures of spread and interpret them in context. So measures of spread are basically two different, we have IQR and we have standard deviation. They're two different ways to tell us how spread out our data is in our data set. So our first measure of spread is IQR. That stands for interquartile range. That's the range of data from quartile 1 to quartile 3. So in the last video, we talked about our 5-number summary and drawing box plots. Remember, quartile 1 is the median of the lower half of our data. Quartile 3 is the median of the upper half of our data. If we were to think about a box plot that looked like this would be quartile 1, this would be quartile 3. So the IQR is this box right here. It's the range of what we have from quartile 1 to quartile 3. We calculate the IQR, or the interquartile range, by doing Q3 minus Q1. We only use IQR as a measure of spread when we use median as a measure of center, which makes sense because on our box plot, median is our measure of center. We don't have mean, so it makes sense that we would use IQR when we're thinking about median as our measure of center. Our second measure of spread is standard deviation. This refers to how spread out the data is, or how far away our data is from our mean. So we're going to use standard deviation as a measure of spread when we use mean as a measure of center. So the first one that we're going to talk about is IQR. Again, IQR refers to the range between quartile 1 and quartile 3. It describes how spread out the middle 50% of our data is, and we calculate it by doing quartile 3 minus quartile 1. So what I want to do is I want to compare the IQR of these two data sets. So let's say that Miss Kirby's class took a math test, and these were her students' scores. So these are Miss Kirby's scores, and then Miss King, her students took a test, and so data set 2 is going to be Miss King's scores on the math test, okay? So let's compare the IQR. To do that, we need to first look at box plots for both of these data sets. I have gone ahead and entered in this data into our online website. So let's look at the box plot for this. So this is data set 1. It looks like our minimum score, our lowest score in Miss Kirby's class was a 24, and the highest score was a 99. Quartile 1 is at 40, quartile 3 is at 81. So I calculate my IQR by taking 81 and subtracting 40. So the middle 50% of the data is spread out by 41 points. Back to this slide, let's go ahead and record that our IQR for this first data set is 41 points. And I went ahead and just put in a copy of that box plot. So again, we calculated the IQR by doing quartile 1, which was 81, minus quartile 3, which was 81, minus quartile 1, which was 40. Now let's look at Miss King's scores. This is what Miss King's scores look like, and we can already tell that compared to Miss Kirby's scores, or data set 1, Miss King's scores are much closer together. The data is not spread out as far. So let's look at a box plot for this data. We can see that the lowest score here was a 68, the highest score was a 92, and then the middle 50% of my data all falls between 75 and 88. So here's Miss King's box plot, or the box plot for Miss King's data. Calculating the IQR, I know that it's going to be 88 minus 75 because I calculate IQR by doing quartile 3 minus quartile 1. When I subtract 88 minus 75, I find that my IQR is 13. So just like we noticed when we were comparing the two histograms, it looked like data set 2 was much closer together compared to data set 1. The IQR reflects that. So in data set 1, the middle 50% of our data spread out over a range of 41 points. But in data set 2, that middle 50% only spread out over a range of 13 points. So the smaller the IQR, the closer together our data is. The larger the IQR, the more spread out our data is. Okay, so talking about standard deviation now. Standard deviation is the measure of spread that we use when we're using mean as our measure of center. And it similarly will describe how spread out the data is, only we base it off of mean instead of median. So using your graphing calculator, we can very easily calculate standard deviation. I'm going to show you that real quick. So here is a graphing calculator. So in order to do this, we first want to click Stat for statistics, and then we want to hit Enter for edit. And now we have a list. So for L1, I want to type in data set 1. So I have 24, I have 45, I have 66, 79, 80, oh, not 78, let's see, 79, 81, 35, 50, 99, 40, 36, 56, 79, 89, 83, and 55. Okay, so now I have all of my data points listed in for L1. Now I want to click Stat again, and this time I want to click Calc. So I want to arrow over to Calc, and then I want to hit Enter where it says 1var stats. So I want to enter on that, and then I just want to keep clicking Enter until I get down to Calculate. And now it gives me a whole bunch of things. This part right here where it says SX equals 22.88750959, that is my standard deviation. So SX 22 point, let's just round it up to 22.9, that would be my standard deviation for this data set. Okay, so to calculate standard deviation on our calculator, we hit Stat, we hit Edit, we type in our data points to L1, we hit Stat again, arrow over to Calc, we hit Enter, 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 and then SX tells us our standard deviation. So looking at data set 1, we did just calculate that standard deviation, and we found that the standard deviation was 22.9. So let's write that in. So standard deviation is 22.9. Now let's calculate the standard deviation for data set 2. So remember, data set 1 represents Miss Kirby's scores, and data set 2 represents Miss King's scores. So I'm going to do the exact same thing that I did with data set 1 in my graphing calculator, except this time I'm going to use my data from data set 2. So let's go back to Stat, and I want to clear out my calculator. So let me clear that real quick. Perfect. So I want to hit Stat, Enter, and now my data for list 1, I have, or data set 2, I have 75, 78, 80, 68, 90, oh, that should be 90, 82, 88, 75, 91, 92, 88, 84, 76, 81, and 69. Okay, now I want to hit Stat, Calc, Enter, 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 and I find that my standard deviation for data set 2 is 7.7 if I were to round it. So SX is my standard deviation. 7.7 is my standard deviation for data set 2. So knowing this, it makes sense that my standard deviation for data set 2 is much smaller than my standard deviation for data set 1. So the larger the standard deviation, the more variable or spread out our data is. The smaller the standard deviation, the less variable or the less spread out the data is. So similar to IQR, a smaller standard deviation means that our data is less spread out. A larger standard deviation means that our data is more spread out.